In this video, we're going to take a look at how to factor a quadratic trinomial. In the previous video, we talked about another method of factoring called grouping. And if you recall, we needed 4 terms in order to factor by grouping. So we're going to use a technique that helps us turn a trinomial into something with 4 terms so that we can use factoring by grouping. Now, if we examine the process, because remember, factoring is essentially undoing the distributive property. So if we look at the distributive property on a binomial times a binomial, in this case 2 linear binomials, we can see what we're going to have to do. So I end up with these 4 terms in the process of doing the distributive property with the 2x and the 3. So I have 2x squared minus 10x plus 3x minus 5. But we can see that this term here and this term here, they're like terms, so they actually end up being able to combine to give us this negative 7x, which is why we ultimately end up with just a 3-term polynomial. So essentially what we're going to be doing is we're going to be taking our quadratic trinomials and reverse engineering, going backwards to try and figure out how to make a 4-term expression. So we're going to basically take this negative 7x and split it into these other 2 terms so that we can then factor by grouping. So let's go ahead and take a look at a few examples to help us with this. So we know we need to take this quadratic trinomial and turn it into a 4-term polynomial. And the way that we're going to do that is we're going to take this middle term and we're going to break it up into a sum or difference of some numbers. Now, there's a lot of numbers that can add to or subtract to 23. So where do we start? Do we just start randomly picking numbers? No, we don't want to just randomly pick numbers. That's going to take us forever to try and figure this out. So we're going to use some other information to help us. So the first thing that we're going to do is the numbers that add to be this 23 need to come from factors of the product of our leading coefficient and our constant. So we actually need to multiply the 6 and the 7. And then we're going to use this little graphic organizer to help us with the whole thought process here. So 6 times 7, that is 42. So we need to find 2 numbers, a number here and a number here, that multiply to be 42 and add to 23. So let's go ahead and take a look at the factors of 42. So the factors of 42 are 1 and 42. 42 is divisible by 2. It's 2 and 21. 3 goes into 42. How many times? What is that? 14. Does 4 go into 42? No, not evenly. Does 5? No, it doesn't end in 0. 6 does. 6 and 7. And then if I said 7, we'd basically be going backwards, right? Because then we end up going back to through the same process. So those are all of the factors of 42. So which of these add to 23? 1 and 42, that's 43. Right here, 2 and 21. So 2 plus 21 is 23. And 2 times 21 is 42. So what we need to do right now is we need to rewrite this trinomial in 4 terms. So the only thing that's really going to change is our middle term. So the first term stays exactly the same. So it's 6y squared. Now this middle term is going to be a sum of 2 terms with coefficients of 2 and 21. So plus 2y plus 21y, right? Because if we combine these, we'd get our 23. And then plus 7. So now we have 4 terms. If we were to add all this stuff back together, because yes, these are like terms, we don't want to do that because that's going to just take us right back to where we started. And we're going to have to go through that whole process again. So now that we have our 4 terms, we're going to just do our method for factoring by grouping. So we're going to split and factor. So what is the greatest common factor of 6y squared and 2y? Well, they're both divisible by 2, and they both have at least y to the first power. What do I multiply 2 by to get 6? So it's going to be 2 times 3. And then if I have 1y here, I still need another y. 2 times what is 2? Well, that's going to be 1. And then I don't need any other y's, right? And so 2y times 1 is 2y. So we know that. In this case, our leading term is positive. So we're going to bring down the addition sign. And what goes into 21y and 7? They're both divisible by 7, and they don't have any y's in common, so that's going to be our greatest common factor. So what do I have to multiply positive 7 by to get positive 21? Multiply by a 3, and then we need the y. And then 7 times what number gives us 7? Well, 7 times 1 gives us that. So again, we can see the 3y plus 1. That is the same, so that's our first group, 3y plus 1. And then remember, our second group comes from what's on the outside, so 2y plus 7. So we have now taken this quadratic trinomial and split it up into a product of two binomials. This is the process of factoring quadratic trinomials. So let's go ahead and try another one. So we want to factor this. So it's 2x squared minus 5x plus 2. So again, remember, we're looking for two numbers that multiply to be this number up here and add to be this number. The number that goes on the bottom is your middle term, negative 5. And the number that goes on top is the product of your leading coefficient and your constant. Oops, so 2 times 2, is 4. So what are the factors of 4? So you're looking at the factors of the top because we want those two numbers to multiply before. So the factors are 1 and 4, and then 2 and 2. Okay. Now, something interesting is happening here because the bottom number is a negative 5. And then our top number is positive. So what has to be true about our two numbers in order to multiply to be a positive number, but add to be negative? If they're both positive, will they add to be a negative number? No. If they're both negative, can they add to be a negative number? Yes. And if you have a negative times a negative, you get a positive number. So that tells us that both of our numbers that go here need to be negative and negative, which means our factors in this should all be negatives. Which of these sum to be negative 5? Well, we have negative 4 and negative 1, or negative 1 and negative 4. Okay, so now let's go ahead and rewrite our quadratic by splitting this middle term. So you take the first term exactly as it is, copy it down, so 2x squared, and you're going to rewrite this middle term with two terms with this coefficient. So minus 1x, or just minus x, minus 4x, and then plus 2. So again, negative x minus 4x gives us negative 5x. Split and factor. Okay, so greatest common factor of these is going to be a 1 and an x. X times what gives me 2x squared, so that's going to be times 2x. X times what gives me negative x. That's going to be a negative 1, right? X times negative 1 is negative x. The leading term here is negative, so we're going to pull out a negative. What's the greatest number that those two have in common? Well, the biggest number is a 2, and then this doesn't have any x's, so that's all we can take out. Negative 2 times what number gives me a negative 4? Well, in order to multiply a negative and keep a negative, I have to multiply by a positive. So I'm going to multiply by a positive 2, and then we need the x. Negative 2, what would I have to multiply a negative number by to get a positive? Well, a negative times a negative is going to be positive. So negative 2 times negative 1 is this. And again, these two are the same. So that's our first group. And our second group comes from what we have here on the outside. So that is, again, factoring this quadratic trinomial. What happens if we have a situation like this? So we're going to, what is the leading coefficient really here for the t squared? Really, it's a 1, right? So it's a 1 times negative 6. That's going to be negative 6 here. And then we have negative 5. So what has to be true about our two numbers in order to multiply to be a negative number? Two numbers that multiply to be a negative means one of them is positive, one of them is negative. Okay, so let's look for factors of negative 6. So negative 6. Well, the factors of just 6 in general are going to be 1 and 6, 2 and 3, and that's about it. Now, we know that one of our numbers has to be positive and one of our numbers has to be negative. Now, if they have opposite signs, when you add them, you end up taking their difference. You subtract the values. And if we know that our resulting number is negative, that means that the larger of our two values needs to be negative. So this is going to be negative, or this is going to be negative. And those are the factors of negative 6. So which of these two sum to be negative 5? Well, it's going to be positive 1 and negative 6. 1 plus a negative 6 is negative 5. So we have positive 1 and negative 6. So let's go ahead and rewrite this. This was our original. Rewrite the original with those two new terms. So this is a t squared. So copy the first term down exactly as it is. These two become the coefficients of our middle term. So it's plus 1t. I can just call it plus t. Minus 6t minus 6. And then let's go ahead and split and factor. So what do these two have in common? Well, the number-wise, the only thing that goes into both of those evenly is a 1. And they both have a t, at least a t to the first power. So what would I have to multiply t by to get t squared? Well, I'd have to multiply by a t. T times what is just t? Well, that's going to be t times 1, positive 1. Again, leading coefficient is negative, so I'm going to pull a negative out. What do these two have in common? They're both divisible by 6. 6 times what is negative 6 times what is negative 6t? Well, negative 6 times a positive 1 is negative 6. And then we also need the t. And then negative 6 times what is negative 6. And then again, a negative times a positive gives me a negative. And I'm going to have to multiply by a positive 1. So this is our first group, t plus 1. And then our second group is t minus 6. So this is the process that you use in order to factor quadratic trinomials. Good luck.